As you watch this clip, think about how the teacher's objective and style engage students in complex reasoning. Notice how paraphrasing and questioning at the subobjective level helps to make new meaning of the content that the teacher did not explicitly give in the lesson.
So why would knowing that be important? I'm just going to pose that question and walk away. Why would knowing that be important?
Knowing that would be important because I think this is a y-intercept. That's where we start. That's going to be the starting point. So we would add that to the equation we get. Because it says doubling every month, so that I think that would be like our rate of change. And then we would add that to the starting point, which is a y-intercept, which would be 1,000.
Yeah, because I did for the equation, I put y equals, and I did y we add, but I did put the 1,000 as the y-intercept, because like you said, that would be our starting point for the equation. So, did you put y in the equation?
So for my equation, since it was doubling every month, it would be 2 to the power of the month, like whatever the month is. And then plus 1,000, which would give me the area covered in whichever month it was.
Yeah, and then you could just subtract if you needed to see the difference between how much the area of the lake is with how much the plant covers. You would just get the area and subtract it with using this equation. What would be y, and that's what your answer.
And then we had to compare it to the equation we did in the first investigation, and it was kind of the same, except like we were multiplying for the first, and then but this one we just have to add because it's like this.
Because it came with the y.
Yeah.
This is the growth, right?
G, what did you say G?
The growth.
Why can't you just put area? I'll just put for the plant.
Area of the plant, yeah.
Nope. Because if it's going at a rate of 2, it's doubling the month. Yeah, the month. So you would have to multiply it by the month in order to know how many months it took in order for it to grow at. Yeah. So technically we're finding how many months it took 1,000 for it to be 1,000.
Covered up each month. So like if you multiply the month, you have to find out how much it covered each side of the area of the lake. So yeah. So for the first month it covered 1,000, right? Covered up for 1,000. For the second one you multiply that, right? You multiply the month. So 2 times and 2 if you multiply it would have covered 2,000. What do you think?
So technically we're starting at 1,000.
Yeah,
We're starting at 1,000 because it's talking about the present day.
So that would have been our words, like what he said.
Yeah, because our starting point
Yes.
our starting point is at
0 months, because it's at the present. And the first month would be what, covered 2,000?
Yeah, it would be 2,000.
And then you multiply that, and then we got 4,000 for the second.
Yeah, so you're doubling every year.
Okay. So what are you guys thinking about with this equation?
So we know that the y-intercept would be 1,000.
Okay.
So
I noticed that you made a graph and we're looking at that here, huh?
Yeah, because if you start at 0 months, since it's the present day,
Yeah.
it's 0 months, which would be 1,000 miles of coverage.
Okay.
So when we look at the first month, it's 2,000. And third month, it would be 4,000, so on. So it's doubling.
Okay.
But
So we're going to multiply 2 times the month and subtract 1,000.
yeah,
Okay. So like for month 3, then I would do 2 times 3, which is 6, and subtract 1,000.
wait. So if you had the first, say you had the first month, 2.
So basically she's saying,
For 2 months it would have been 4,000.
so basically she's saying 2 times month. So
So we think this all wrong. It's we don't focus on the, since we already have the month. Wait, no. Since this is what's doubling. The area of the plant is what is doubling. So in order to use the equation, we have to use 100 y-intercept. Wouldn't the y-intercept be the slope?
Y-intercept?
Yeah, you could use a y-intercept as the slope.
So we're multiplying the number, the area of the plant square
By month.
by months. So if you're multiplying the number of months, you also have to multiply the number of the plant.
Oh wait, no. But yeah, you have to double it. So like, so you have to double this, but you still have to figure out if someone asks you, say someone asks you, what happened in 3 months? How much did it cover in 3 months? We have to tell them that in 3 months, so and so this covered. So what you're saying is that, so they're gonna ask you how much is in 3 months, and you're gonna say it's double. So every month it's double.
Because you guys said one of the problems would be like trying to get this plant before it takes over the whole lake, right? So a scientist or a mathematician might be interested in figuring out the area at any given time. How do I use this equation to figure out the area of the plant after, say, 12 months? What would I need to do? Okay, so let's raise our hands, please. What would I need to do here? Danae, what would I need to do?
You would need to substitute 12 for m, because it would be the number of months. So you would substitute 12 for m. So you would end up doing 1,000 times 12. 1,000 times 2 to the power of 12.
Did anyone solve that out? What's the area of the lake at that point in time, Billy?
We had 4,096,000.
Feet squared, right? Okay, so we could use that substitution just like we were talking about at the start of our lesson when we looked at that other equation. We're using that same idea of substitution there. If the plant tripled every month, how would it change this equation? Rosa, how would it change the equation? Okay, what number would change? What did she say? What is the growth factor at present? 2. Okay, so instead of the growth factor being 2, it would become a 3, right? What if, so that would, it would increase the area of the lake, wouldn't it? We saw that with the arubas. Thank you for pointing that out. What if I decided to change the present area of the plant to 1,500 square feet? How would that change the equation? Put your thumb here when you know. How would it change the equation if I changed the at present amount to 1,500 square feet? What part of the equation would change, Ricky?
No, the lake. And
What number would change?
the 1,000, because you're going to change the lake to, you're going to change the president, you're going to change the plant, the plant is there right now.
The right now amount is going to change to what? 1,500. So instead we'd have this number there instead, right? Yeah. Okay.
The teacher received a 4 for critical thinking because the students used complex reasoning at multiple sub-objectives to make new meaning not provided by the teacher. The teaching strategies employed allowed the students to construct their own understanding of the lesson focus question as they grappled through the sub-objectives. Do all questions help students reach critical thinking levels? What types of questions might push students to the next learning level?